Managing Databases Part 3 of 3. In this nugget, we tie up our general consideration of databases in MySQL 5 by looking at a third and extremely powerful DDL statement, the drop database command. In other words, what do we do when we're ready to decommission or retire a database, and what are the ramifications, both in the host operating system as well as within your MySQL instance, of doing so. In the second half of this nugget, we'll take a closer look at obtaining database metadata. Thus far, we've been using the show command quite a bit, and that works really fine as far as it goes. However, in this nugget, I'd like to introduce you to the information schema system database, and I'll show you some more flexible and robust ways to get data about data. Dropping a database. Thus far, I've showed you the create and alter DDL statements. Those were used, as you know, to bring new objects into existence and to make fundamental changes to those objects. Now we have the very powerful drop command. The first thing you should understand is, like create and alter, we can use drop among many scopes. We know that on the outer level of things we have the database, which really is not much more than a container for other objects. And what are those other objects? Chiefly, we're talking about tables, aren't we? So therefore, we can drop individual tables. Drop, of course, is a synonym for delete. Or we could drop the database. If we drop a table, of course, that's going to leave the parent database alone. By contrast, if we drop the database, any and all objects within that database, including tables, is going to be deleted. Now, many shops, with good reason, are hesitant to delete anything. It's a question of building your data warehouse, which takes in disparate data from all the various and sundry nooks and crannies of the organization, and never deleting, always archiving. However, at the very least, as a database developer, as you're testing out new objects and new techniques, you're going to leverage the drop command just to avoid clutter and unnecessary disk space usage. The basic syntax in SQL for drop database is simply drop database and then the name of the database. As we've seen in previous nuggets, MySQL doesn't give you any confirmation or asks you, are you sure you want to drop the database? It just goes ahead and does it. So again, be very careful when you use this command in production. Just like we saw with the create statement, we can throw in the if exists clause, always good best practice, which will instruct the MySQL parser to look and see if that database actually exists in the system or not. Another way to drop a database is from outside the MySQL client. We've used the MySQL admin tool. From an elevated shell prompt, we can run MySQL admin drop database name to dump a database in the operating system. One thing you should understand is that when you drop a database, you're not only removing the logical object from within the MySQL instance, but also in the host operating system, in your data dir, your data directory, you're removing data files. So remember that drop can never be underestimated in its power. If for no other reason, this should be a good reason for you to take backups on a very regular basis, such that if you were to find out that you shouldn't have dropped that database, you can restore hopefully not too old of a backup copy. Now, similar to that complaint that Microsoft Windows users have, at least up until recently when uninstall routines have gotten better, it seems, there is the question, well, if we delete a database in a MySQL instance, is there any detritus left behind? This is what the gotcha is all about. As it happens, user privileges are not automatically removed from the MySQL database. You might remember that MySQL is the system database that's crucial to the operation of the entire MySQL instance. And in particular, the MySQL database is where your user accounts, your MySQL users are defined, your grant tables or your permissions tables for all other databases and objects in the instance. All of that stuff is tracked in one or more tables in the MySQL database. And as it says here, those grants, those user privileges, are not removed along with a database drop. Now that can be a problem because if somebody comes along and builds a new database, let's say we do a drop database test DB, And then a week later, another administrator logs into MySQL and does a create database test DB. Well, we might see unexpected permissions issues unless we go into the MySQL database and clean out manually those leftover user privileges, because an object name is an object name after all. Let's take a look at some practical methods for obtaining database metadata for database and database objects in MySQL 5. The first way is using the MySQL extension show. I'll also tack onto that describe. Both of these are really handy-dandy terse ways to retrieve metadata from your database and database objects. Now, if there's an advantage to the show and describe commands, it's their simplicity. It's easier to remember. If there's a disadvantage to the show or the describe statements, it's their inflexibility. Basically, show and describe are good for get in and get out, really fast data. But if you're looking to pull complex metadata or ask more serious questions of your database, stuff like show me all of the tables in this database that have more than 1,000 rows, or show me all the tables in all of my databases across the entire instance that have a certain number of rows, or have a primary key, or don't have a primary key. These are more complicated questions that certainly can't be answered with the show and describe statements. There we're going to need to turn our attention to a built-in virtual database called information_schema. This is a standard ANSI ISO construct, and it provides an interface for metadata. Now, meta is a Greek word that comes to us from Greek. I guess I just said that, right? But anyway, and meta means above, so metadata is data that's above the data. You've got the actual data in the database, and then the data about, or that describes the data in that database. Metadata. An information schema, like I said, as a database, therefore contains a bunch of tables. Technically, they're views. We're going to be covering views and tables in future nuggets, so hang on to your hat about that. These views we can query as a DBA, and because they are views, we can do really cool things like create joins, which allows us to link together more than one of those information schema tables, because the tables are split out pretty granularly. In just a moment, I'll give you a run and I'll show you all of the tables that are contained in the information schema virtual database. Incidentally, the reason why the information schema database is referred to as a virtual database is that it doesn't actually store any data per se. It stores these view definitions, but when you query those views, you're actually kind of going through the information schema and you're hitting your other databases that may be within that instance. You see what I mean? So really, information schema provides a window that gives you access to the rest of your database, tables, and other objects. Third method for obtaining database metadata in MySQL is an external utility called MySQL Show. So this makes at least the fourth external utility we've looked at thus far. Of course, there's the MySQL Terminal Monitor. There's the MySQL Admin Tool. There's MySQL Dump, which we looked at in the previous nugget. And now we have MySQL Show, which enables us to, you guessed it, show various things. Show me all of the databases on this instance. Show me all of the tables on this instance. Stuff like that. And you can have access to that information from outside of MySQL and within your shell prompt environment, your C prompt or your Linux shell prompt if you're in that. Now, this introduces a quick question that I haven't formally addressed yet, and that is, you might be asking yourself, what is the deal with these external commands? Why does MySQL even support these external commands? Isn't it good enough to just have the MySQL Terminal Monitor where we can log in and execute statements, select statements, and so on directly against the information schema database, or we could use show and describe, etc.? Well, a good response to that, friends, is that you as a MySQL administrator, if you don't already find yourself in the situation, may be faced in the future with tending not just one, not just two, but perhaps dozens or hundreds of instances of MySQL Server. When it comes to answering questions like what databases are associated with which instance, you're definitely going to want to use an external utility like MySQL admin or MySQL show that you can get to from a shell script and create, let's say, a batch job that can just iteratively run MySQL show against all of the MySQL servers in your organization and return that data to, say, a comma-separated value file. See? So really, administrative flexibility and administrative automation are the two chief reasons why we have this bucket load of external utilities in MySQL 5. In my humble opinion, they're indispensable tools. In this whiteboard, I wanted to give you a screenshot pulled from the MySQL reference manual that lists all of the show statements that are supported by MySQL 5.1. This is the whole kit and caboodle. I apologize for the text in the screen capture being kind of small. What you'll want to do is go online and visit the MySQL reference manual for the version of MySQL that you're running and look up the article that shows you these show statements. What we're going to do here is just take a quick glance through here to just get a better grasp of the types of metadata that we can retrieve. Now, some of this we've been running a lot. I've showed you the show character set and show collation show statements. Of course, show databases, show tables. You can show indexes. For permission stuff, you can show grants. Show storage engines is particularly important to see which storage engines have been installed on that instance of MySQL. Show tables, show triggers, show warnings, show plugins. Now, you certainly don't have to memorize this list for any of your MySQL exams, but you should know, in addition to the basic show statements that we're using over the course of this Nugget series, you should study this list and look for any others that you think might reasonably pop up in your day-to-day work as a MySQL administrator. In contrast to using the show statement, as I mentioned earlier, another thing, a more powerful and flexible method for metadata retrieval, is for you to query the information schema database. And again, at right, we have a graphic taken from the MySQL reference manual that shows the results of the command show tables from information_schema. And here's an alphabetized list of all of those views. And they are, in fact, pretty granular. Character sets, collations, columns, engines, files, process list, schemata, privileges, statistics, tables, triggers, users, views. And it's simply a case of running select against one or more of these views and doing the appropriate filtering and sorting. As previously discussed, information schema database querying tends to be much more flexible than show. Some of the reasons why: when you're querying the information schema database, you can redirect output. Instead of just running show databases and getting the results on your screen, you can use select to redirect the output of an information schema lookup to a file, for instance. Another thing we can do is select individual columns. If we run a describe table command, the describe command in MySQL returns just a certain number of columns back that you have no control over as an administrator. Again, the power of the select statement is that we can specify exactly which columns we want to see and what order we want to see them in. We can even include columns in our filtering, but suppress them in the query results. Very powerful stuff indeed. As previously discussed, this is a big one: the notion of being able to create more complex information schema lookups by taking data from more than one table at once. So we can ask very detailed questions of our databases and get those answers back in many different forms. And then, of course, as I said, we can use wildcards, we can use the like operator, we can use the percent operator, we can use the where clause to do filtering, we can use the order by clause to do sorting. All of the neat gifts of the select statement, essentially. I hope that you're as convinced as I am that the information schema is a very, very invaluable and, frankly, bursting with viable information database in MySQL 5. MySQL show. In our use of MySQL admin and MySQL dump thus far, I'm sure I've impressed you with the fact that the syntax for the commands here are pretty darn terse, and that's no exception with MySQL show. From an elevated shell prompt, you can just run MySQL show with no other parameters, and the results are going to be all of the databases attached to the specified instance of MySQL. Now, if you don't even specify a host name or an IP address, then MySQL show, of course, is going to return databases on the local MySQL server. MySQL show space DB will list all the tables in the specified or given database. MySQL show DB table will list all the columns in the specified table. That can be useful again for database design purposes. If you need to create a new database, a lot of times the best place to start in your table design is to query the columns of existing tables and basically copy their structure. And then finally, to list indexes that may be defined for a particular table, we can run MySQL show with the keys parameter along with the target database and table, and that'll just tell us the indexes, or if you prefer, indices that have been defined there. In our demonstration, we're going to put into action the principles that we learned about thus far in this nugget. I'm going to show you dropping a database, but in particular, we're going to look at the file system ramifications of doing that action. After we do that, we'll spend the rest of our demo time generating metadata. Using our built-in internal commands, we'll query the information schema virtual database, and then we'll go out into a shell prompt and run MySQL show. In this demo, we're going to be working with the drop database command and also looking at retrieving database metadata. We are here on MySQL Nugget Windows Server 2008 box, and to begin, I'd like to open my my.ini option file and draw your attention to a couple parameters in the MySQL-D, the server section of the file. First of these is the base dir parameter. This is, as the comment tells us, path to the installation directory. All paths are usually resolved relative to this. This is going to be your basic where MySQL is installed on the server. However, just underneath it is what we're particularly interested in, the path to the database root, also called data dir. Remember, this is where your files are going to be stored. A third parameter that I've been asked a lot by colleagues, how do I change the default storage engine that's used in the instance? Best way to do that is under the MySQL-D section, if you don't already have a line default-storage-engine, you can go ahead and add it. For instance, if memory serves, the my.cnf file in Linux does not have this setting in the option file by default. You can just go ahead and type that in, equals, and then you can specify what storage engine you want the server to use by default if one is not specified at table creation. The two most common, of course, would be myisom, which is frankly what's used by MySQL anyway by default, but I could change this to say inodb if I want to. I won't though. I'm going to navigate next to the data directory, which I do happen to have a shortcut of on my desktop, and we're just going to keep our eye on these files and watch what happens as we build out a database, populate it with a table, and then start striking away or deleting those objects. You'll also notice that right now we're using the default myisom storage engine that MySQL uses anyway by default. So we should expect to see files with particular extensions. We covered that a couple nuggets ago. All right, so let's get logged in. And we're going to create a database called DropMe. We'll then use that database and populate it with a table. And what I've done here is created a table called table. Remember, if not exists is important so that we don't inadvertently blow away a table that might already exist by that name. This table has two columns. One, an ID column of the integer data type. I've set this to automatically increment for every row created in the table. And finally, I've attached the primary key constraint to that column. Now, between the auto increment and the primary key assignment, I can tell you in advance that we can expect MySQL Engine to build us a table index for T-table without us having to explicitly create an index. And you'll see that in the file system in just a moment. The second column that's in this table I've just called name, and it's using varchar 30 as its data type. So let's go ahead and create this table, and then we'll say show tables from dropme. And there's our T-table. So far so good. Next I'll just insert a quick row into T-table just to make sure that we've got a tiny bit of information there. I'm going to just pop in a new row here, letting the auto increment give me the ID value, and I'm going to set the name column to the string hello. So if I do a select splat from T-table, I see that I've got data there so far. All right, well that's all well and good. Now let me minimize the MySQL terminal prompt, and let's go into our data file and see what's gone on. Sure enough, we see that a file container has shown up in our data dir called dropme, named exactly the same way as I named the database. And then if we double left click it, let me refresh my view here, you can see we've got a table file, a .frm file, and we also have a db.opt file. You'll recall from an earlier nugget that the opt file is a database level parameter file that stores your character set and collation data. Now you might have noticed that we didn't have an myd or myi file in our dropme database directory, and that leads me to the suspicion that for whatever reason, even though my data file specifies the myisom engine, that this table must have been created within ODB instead. So what I'm going to do is run alter table T-table engine equals myisom. And what this is going to do is switch on the fly the storage engine that's being used for that table from InnoDB to myisom. Remember, this is an example of how pluggable, really it's hot pluggable, the storage engine architecture is in MySQL. And sure enough, if we navigate back to the dropme folder, we now have, in addition to our opt and form file, we have a ttable.myd, that's our MySQL data file, and ttable.myi, that's our index file. When InnoDB is used, all the data and indexing and all that gets thrown into a single file called ibdata1 that exists in the root of your data folder. So just a engine-specific parameter there. The reason why I want us to use myisom is because myisom breaks out the file separately, and it's just a little bit more obvious what happens when we issue the drop statement like we're about to right now. Alrighty then, so let's come back to our terminal monitor here, and let's drop the table, T-table. Again, no hesitation at all. Show tables from dropme, and there's an empty set. So without any hesitation, without any confirmation, that single command, those three words, drop table T-table, nuked that table that previously contained one row. But the drop would have gone through even if that table had 1,000,000 rows in it. Let's come back to program data, and you see that our dropme folder now has nothing in it. The form file is obviously gone. The myi and myd are table-specific data and index files respectively. Those are gone as well. Now, our coup de grace, so to speak, would be, not create, is to use the drop database command, dropme, and sure enough, if we show our databases, it's gone. Well, let's come back to our data folder, and now it's all gone. That is to say, the dropme folder is out of the file system. Don't be fooled though. Remember what I told you before. We still have some activity happening in the MySQL database, or leftover grants from our previous work. Next up on our agenda in this demo is to query for metadata using the information schema database. And you'll always see it here as long as you're logged on as a root or administrative user in MySQL. You'll see information schema revealed in the show databases command. So what we can do is use information schema and then run a show tables command, and we'll see all of those views just like I showed you in the whiteboard section of the course. So this is the clay, so to speak, out of which we can fashion queries to gather data about our server's data. And the queries can be rather sophisticated. It's not just a question of select star. Remember, you can add functions into these queries, we can do joins, and so on. In fact, I'm going to write a query now that's courtesy from the website thegeekstuff.com. There's some really excellent learning resources on that site. Check it out if you would. And this query asks the question, show me all of the tables on this server that have more than 1,000 rows. And this is a pretty cool query, brings in a lot of intermediate to advanced topics. I'm going to get you started in here, even though we haven't yet formally covered the select statement. We're diving right into about maybe shoulder deep water here if you're a newcomer to MySQL, but follow along and I hope I'll make this nice and clear for you. To make things a little bit easier in terms of differentiating our SQL statements from our objects, you notice that I've capitalized the SQL here. Actually, we're selecting two columns. We're selecting one column that we're going to call table name, and then a second column called table rows. And those columns are coming from information schema.tables. This is probably the most popular table in the information schema database because it gives you access to, you guessed it, all of the tables across your entire MySQL server instance. Now, this gets a little bit hairy, a little bit more complicated, because instead of just grabbing the columns from the information schema.tables table as they are, what this query does is it runs a built-in function called concat. Very useful function, and in a nutshell, what concat does, concat is short for concatenation, and concatenation means to join together. What we're going to do here is we want to see all of the objects in the database that have rows that are greater than 1,000. And we want to see actually the name of the database, period, and then the name of the table. Concat allows you to take, for instance, data from more than one column and combine them together. You could concatenate, for instance, a first name column and a last name column to make first name, last name. And you would use, in this case, we're grabbing the table schema column. That's going to give us our database names. And then I'm saying comma. And then in single ticks, we're putting what's called a string literal. This means that take the table schema, return that, throw in a static period separator, comma, and then bring us the table name. Finally, if all of that wasn't too complicated enough, we're aliasing the results here. And we're displaying the results of this concat function as a different name just to make it easier for us to understand. Because after all, we're pulling data from more than one column here. So as is a keyword in SQL that enables you to create an alias or a kind of a shortcut name or a custom identifier for another column. You can alias column names all day long. And you can even alias table names in SQL. It can make complex queries a lot easier to understand when you do so. All right, so those are our two columns that we're grabbing. Where are we pulling those columns? Well, you know, from information schema.tables. And then we do our filtering. Where is the SQL command for doing row level filtering? And the argument here is where the rows column in that table's table is greater than 1,000. Finally, we can provide ascending or descending ordering by using the order by clause, and we're going to order by table rows descending. In other words, show me the tables that have the highest number of rows first, and then gradually work our way down. And as we see, we only get one reply, or one row back. In the world database, there's a table named city that has 4,079 rows. All right, well, we have our question answered. Tell you, because that table is so interesting, why don't we show columns, see here we're using the show command, from tables. And so this is giving us a run of all of the columns from the tables table in the information schema database. And it's nice to understand these and what they mean so you can write complex queries like we saw a little bit earlier. Now remember that schema, when you see that, refers to a database. So table schema actually is going to map to a particular database. As a Matter of fact, why don't we do a select table schema, comma, table name from tables. And this gives us a list of all of the databases and then the tables that map to those databases. So for instance, in the world database, we have city, country, and country language. Easy peasy. Finally, just for grins, let's do a show engines. This gives us a response that tells us at the server level or at the instance level, which storage engines do we have support for. And it looks like most of them, besides federated, we have support. And sure enough, this reveals that on this server, InnoDB is set as our default engine. Well, we can change that easily enough, can't we? But for now, though, what we'll do is we'll quit out of MySQL, clear our screen, and we'll move on to the MySQL show command. MySQL show, with no parameters, as I've told you before, returns all of your databases. If we do a MySQL show and then pass in a database name, it tells us the tables. Finally, if we do MySQL show database table, it basically gives us the same response as doing a describe on that table. You'll remember also, and finally, we can do a MySQL show with keys, passing in the name of a database and the name of a table, and it'll give you full information on any indexes that have been created there. In this case, we've got one. Looks like it's a primary key index that keys on the ID column. Managing Databases Part 3 of 3 Review. Well, we've come quite a distance so far, haven't we, friends? Not only do you have a pretty good idea of what MySQL is and how it works architecturally, but by now I would hope that you have a pretty comfortable understanding and navigation skill within the MySQL client, and then using some of the external tools. In this nugget specifically, I showed you how to drop a database, and we looked at all of the ramifications that doing that action has in the server, and we looked also at more than just the show and describe commands, but I showed you other methods for gathering database metadata, or data about data. I'll tell you, friends, I can't overestimate how important it is a skill for you to be able to gather meaningful metadata. The first thing you're going to do as a MySQL contractor when you visit your customer's site is run some of these commands to get a feel for what you're working with. I can essentially promise you that that'll be the case. Therefore, these skills that you're building aren't only going to get you past the CMA certification exam, but also get you a heck of a lot farther along in your journey as a MySQL professional. I hope that this has been informative for you, and I'd like to thank you for viewing.